Hello everyone, my name is Daryl. I work as a software developer, and in this video you'll see how I naturally work through a LeetCode challenge. This is a problem that I'm seeing for the first time, and I'll explain myself as I work through it. My solution won't likely be the best or most efficient. It'll be the one that I come up with first as I'm working through the problem. So let's start looking at this one. This one is rated as easy. It's number 70, climbing stairs. So this one says you are climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. How many distinct ways can you climb to the top? So for their examples, you have if n is equal to 2, then the output is 2. So there's only 2 ways to climb to the top, either 1 step and 1 step or 2 steps. N is equal to 3, then there are 3 ways. You can do 1 step, 1 step, 1 step, 1 step plus 2 steps, or 2 steps plus 1 step. And n can be between 1 and 45, including 1 and 45. Okay, so what I'm thinking about doing for this one is actually something that I learned in discrete math. So I'll kind of code it out and then explain myself, kind of more so after the fact. So first I'm going to need to, well, first I'll copy over this function. And then I'm going to need to create a separate function called choose. And we'll have, both of these are going to be integers. Or let's just do, yeah, first int and then second int. And this can be private. We got val top, and that's going to be, well, let's say variable top. We'll set it start to equal to 0, and then we're going to repeat second times top multiplier. So we're going to make it equal to first. So top plus equals, or times equal, or first we'll set top to first. First we also need there's one base case that we need to handle here, that if second is equal to 0 or first is equal to second, then return first. And we need this to return an integer. So here, top multiplier and top multiplier minus minus. And then we're going to need to do something similar for the bottom. If any of you guys have taken discrete math, you know what I'm doing. I'm just trying to make it so you can do something, choose something else. I'm just making a function that handles that calculation. It has to do with Pascal's triangle. All right, so we're going to set bottom multiplier. Let's set it equal to second minus 1, because we're going to set bar bottom is equal to second, and repeat second minus 1 times, and we're going to say bottom is equal to, or as times equals bottom multiplier and bottom multiplier minus minus. We're going to return first divided by second. Now really quickly, I want to make sure that this choose function is working. So let me just do, we're just going to do a few examples. So let's just do first 10 choose 0, and we'll do a print solution dot climb stairs. We can pass whatever, because I'm hard coding in here just to test this choose function. This one 10 choose 0, that should be okay. So no, this should be returning 1, not first, if it hits that case. Yeah, okay. And then let me test. I have a few examples that I just kind of want to test here. That one's equal to 9. That's good. 8 choose 2 is 4. That should not be. That should be 8 times 7 divided by 2. So let's do a quick debug and see. So it didn't repeat because, okay, it should have repeated that. It's because it made it, should have been 1. Second minus 1 is 1. So it should have run once. Top is equal to 56 right here. So by the time you get here, the top is 56, the bottom is 2. Yeah, so 56 divided by 2 would be 28. Why is it showing 4? Let's quickly do a var results. Why would it be equal to 4? Oh, because we're doing first divided by second. Come on. We want to do top, bottom. That's better. All right. All right, so now that's 28. That's 9. Okay, let's try 7 and 3. That should be 35. Right. Got that. And 6, 4 is 15, right? Yep. And then the last one I wanted to test was just 5 and 5. That's a 1, and then we'll quickly do 10 and 0 again. Perfect. So it's working correctly. All right. So now that we know that that function is working properly, let's actually do this. We can kind of minimize that. We're going to var. I'm going to create a top here. It's going to be equal to. Okay, so we need to figure out how many 2's we can possibly have, which is going to be amount of 2's is going to be equal to the floor of n divided by 2. Okay, so it's either going to be a 0.5 and then round down, or it's just going to be, because it's even, it's just going to be an int. Yeah, I want to make sure that's an int. All right. So top is going to be equal to n, because we could always just have 1's. And bar bottom is going to start at 0. Bar result is equal to 0. And we're going to say while top is greater than or equal to bottom, result is going to be equal to plus equals choose top, bottom, and then top minus minus, bottom plus plus, and then return result. And now I know what, so 10, if we put 10, I think the answer is 89. Oh, we never use the amount of 2's. We want to do, we need to do, well, let's just see what that does really quickly. That gets 89. We don't need to calculate the amount of 2's then, because it's always going to end up being this way, because that is the correct answer. So we need to, if we're going to go ahead and try this out real quick, we need to import that and then copy all of this into solution. Let's run their example here. So that example worked. Let's submit. Okay, so it didn't get the right answer for 35. So let me input 35 here, and let me see, how many did it go through before it failed? And expected a lot higher of a number. Details. Okay, so we got through over half of them. Anyways, we output that, it expected that. So really quickly, I just want to kind of debug through this. So first we have 35 choose 0. Then we have 34 choose 1. It's going to keep going. This is all looking fine to me. And then it exited there. Let me go through that one more time. $13, $14, $15, $16. Okay, so right now it's 18 choose 17, which means that we have 17 twos and 1 1. Right, so right now top is 17 and bottom will be 18, so that's where it's going to exit. But it's saying that we have another value higher. Really quickly, let me just print line. We're going to say first use second sure, you can do that. I just want to see. You got a much bigger answer, which is quite interesting. Actually, let me take this and really quickly, I'm just going to put this here. I want to do just like that, so we get the value. Ooh. Well, that would be why we got some issues with 27 choose 8. That's interesting. So let's look at what's going on with that. All right, let's look at this. Okay, so this totally just has to do with the fact that we're using integers here. Let's just use longs. And let's see if that gets a better answer. Um, well, actually, okay, all right. So these, the inputs can be ints. We know they're going to be short. But top needs to be a long, and bottom needs to be a long. This, though, is going to be a smaller number. Because they always want it to return an int. So that looks like a proper answer. So let me uncomment this, comment this out, comment this out, and see what result we get now. Okay, now we get the right answer. So I'm going to go ahead and get rid of this, get rid of this, copy this over. So let's run the example, and then we'll run code. Okay, to be honest, this probably once again has to do with the variable type we're using for this. We might need to use big integer. Okay. And same thing here. Too big integer. Let's run with 44. Okay, now we got the right answer. Let's copy this back over. I'm sure this isn't going to be too great on memory since we're using big integer. All right, we got the answer. So of course, this is apparently a pretty poor solution. I know it was going to be a bit bad on memory usage. I wasn't too particularly sure it was going to be bad on runtime. But let's quickly go over the code. And so like I said, I actually ended up utilizing information from my discrete math class, which is very interesting. So going over the code real quick, this all kind of revolves around this choose function. So once again, this is coming from my discrete math class. So basically what we're doing, so if we are, let's look at an example really quick of 10 as being an example, all right? So first, we want to consider everything being ones. So when we do, the first time we run this, it's going to be 10 choose 0. It's going to be 10 and 0 here. And this answer ends up becoming 1 because this is the case where we have 10 ones, okay? So there's only one way where you can have 10 ones, and that's a possible result of this answer. You can do 10 one steps. Now, let's make one of those, for the next iteration, let's make one of those ones a 2. So now we have 1, 2, and 8 ones, okay? So that means we have 9 items, and one of those items is a 2. So we have to consider if we have 2 and then all ones, that's considered one possibility where we can get the steps to go up to 10. But we also need to consider, like, what if there's a 1 and then there's a 2 and then there's the other ones, or 2 ones and then a 2 and then all the other ones. So this is where we get, so this is going to be 9 because we have 9 items. Choose 1. We're choosing where to put the 1, 2. We're choosing where to put the 2. And that's going to end up being 9 because there's 9 possible places that you can put the 2 where you can get the answer. And so you just keep going through this pattern where you keep subtracting 1 from the possible amount of items, because every time we transform one of those 1s into a 2, we have 1 less object in our collection. And we're always choosing where the 2s are going. So after doing 9 choose 1, we're going to do 8 choose 2. But the way this ends up going with the calculations for 8 choose 2, for example, is you have to do 8 times 7 for the top of the equation, so 8 times 7, and you have to divide it by the bottom, which is going to end up being 2 times 1. So that's kind of the way the pattern works with these chooses, is you do the top starting with the biggest number. So if 8 choose 2, you start with 8, and then you're going to multiply it by 7. We're only going to do those 2 because we're only choosing 2. And then the bottom is going to be starting at the bottom, so 1 times 2. So 8 times 7 divided by 1 times 2. 7 choose 3 is 7 times 6 times 5 divided by 1 times 2 times 3. 6 choose 4 is going to be the next one, and that's also the same as 6 choose 2, but that's kind of a Pascal's triangle thing. But for 6 times 4, it would be 6 times 5 times 4 times 3 divided by 1 times 2 times 3 times 4. And so you just keep doing that until you either get to the point where, in this case, we do 5 choose 5, which means that all of them are 2s, and there's only one possibility to have all of them be 2s. You can't change that at all. Or the case, if it was like 11, you'd end up getting 6 choose 5, and then you couldn't do the next one because it would be 5 choose 6, and you can't have the bottom be bigger than the top. And so that's basically all we're doing. We're just using this choose function, using that very simple formula of, since we keep transforming one of them into a 2, we keep increasing the bottom, decreasing the top, and we do that and add up the result all together, and that's the possibility. So once again, to be honest, this is more of a discrete math kind of question and way to solve it than a programming thing. But I guess this is why they have you take these classes in college, because otherwise I wouldn't thought of that way to solve this problem. So I was glad I was able to use my math knowledge on that one. All right, that's going to be it for this one. Thanks everybody for watching. Hopefully that helped. Catch you guys next time.